I'm really glad to get a chance of having a presentation about our research. In the beginning, I will introduce my team, Saving World and Energy of Next Generation, shortly SWEAG. We chose the team name because the research pursues to expand the use of hydrogen ultimately, and I will show you how we make the way. I will introduce my research in the order of background and purpose, improvement factors, procedure, schedule, and division. Chapter 1 is about background and purpose. Firstly, we decided this topic to overcome global warming. The usage of conventional energy sources that produce carbon dioxide, which is responsible for global warming, is now should be reduced after the net zero announcement. And hydrogen is considered as the best replacement for conventional energy sources. Nevertheless, hydrogen has danger of having exploded when its percentage in the air exceeds 4. These are the cases of disaster caused by hydrogen explosion in Bunsan and Gangwon. Both explosions resulted in financial loss and casualties. Problem is, it's impossible sensing hydrogen with the sensory organs of human beings because it has no color and no scent. So, inventing a hydrogen detecting sensor is an essential task for future energy usage. The picture on the left side is showing the structure of conventional hydrogen gas sensor, which is the tin dioxide used as sensing material. And the picture on the right side is showing the graph of its operating temperature. As you can see, the operating temperature of tin dioxide hydrogen sensor is over 150 Celsius. This means the sensor can't save us under that temperature. To solve this problem, we concluded that sensor should have lower operating temperature.
The next part is improvement. There are a total of 2 factors. The first is the self-heating of CNTs. Before that, we chose to use carbon nanotubes because of high flexibility, strength, heat conduction, heat resistance, and then also reactivity. Therefore, unlike the metal oxide dust sensor they use on external heater, the CNT can be self-heated by itself applying a high voltage without an external heater. Using this method, operating temperature can be lowered to around 200 degrees Celsius. However, DOE standard states that hydrogen gas sensor should operate between 70 and 150 degrees Celsius. So, we reduce the operating temperature once again through palladium deposition. Palladium is generally used as a catalyst and has high reactivity with hydrogen. Therefore, the palladium thin film will be deposited by sputtering through the holes in the PDMS previously perforated. And then we expect our device could operate under 30 degrees Celsius. In a similar experiment, when palladium was deposited on bulky paper of CNT by 20 nanometer, the reactivity at room temperature will increase. In conclusion, the expected result of our study is to develop sensors that detect hydrogen at lower operating temperatures through self-heating and palladium deposition to CNTs.
Now we'll talk about our experiment procedure. First, it starts from making PDMS. The reason for using PDMS is that PDMS has lower reactivity than CNT. Then PDMS can reduce reactions of other external factors. For several mixtures of PDMS, finally we made PDMS suitable for the experiment through failure. PDMS is made in a 3:1 ratio of 50 gram silicon and 5 gram of hardener. The total amount of PDMS was adjusted to produce about 3 gram, 5 gram, and 8 gram. The about 8 gram PDMS, which had the largest amount, was the best condition, and then multiple CNT was attached on the PDMS. The figure of the left shows 3 days of hardening process, and the right one is well hardened PDMS. Now is the time to attach CNT to PDMS. First, we need to make a hole in the PDMS. The reason is that when hydrogen is detected, it helps the CNT contact hydrogen in the atmosphere easily. We put the CNT to match the lattice of the hole and cut it as shown in the figure on the right. We named it as a unit.
After creating the units, the next step is to attach them to a chip. These are our chip's image and schematic of it. We designed the chip 5 by 5 millimeters with electrode is slightly curved. The reason we carved electrode is to make currents flowing over CNT only. As it prevents contacting with the electrode surface, it makes reducing the loss of heat generated by the resistance of CNT, which is increased through self-heating. This is our unit, which consists of PDMS above vertical CNT. We will attach it on our chip. To ensure good attachment, we decided to use a plasma cleaner. However, plasma may harm PDMS, so we choose to clean the chip instead. After 1 minute passed, we can find that the adhesion between the chip and unit increased successfully. Our goal in this step is to align the chip's electrode and the unit exactly in the correct orientation. We used an optical microscope to achieve this. With the chip on the bottom and the unit placed on the top, with CNT facing down onto the chip's electrode. This picture is our experiment moment. The right picture shows the moment of attachment, with the unit's hole aligned properly outside of the square electrode. This figure is the result of our deposition, and the unit is now ready to be attached to a PCB substrate. With silver paste and wire bonding, we will create a sensor and test the sensor's performance in different conditions. This is an example of our completed sensor. And we have also prepared a short assembly video.
Let's start the presentation. Next, this graph is our research schedule. Last January, our members have decided this topic together and started to search information of it. In March, while searching information, they received materials to make gas sensor and began to make PDMS. From now on, in April, we started to make CNT gas sensor, and after in the mid of April, we will test its performance. We plan to produce secondary experimental result, which is deposition of palladium by June. And last of our schedule, we would like to complete the graduation work by preparing a report while analyzing and reviewing the data as a result. Finally, in this presentation, it is our division of role. As you can see, each 5 members did their own work successfully, and the underlying part mean their main role of our work. Thank you for listening our presentation.